Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 38 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear. If you don't, look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. I am going to teach you trigonometry. Wait, don't run, don't click off, don't panic. What I will commit to you is I will teach it to you in a simple way, step by step, where you will not only understand it, but you'll also understand why it is important. And one reason it is important is it's going to be needed in our upcoming lessons. And so rather than you just be totally confused in the upcoming lessons, I'm going to teach you a little trigonometry, and then you're going to enjoy and really fully understand those upcoming lessons on our IMU, on our accelerometers and gyros. And it's going to be a really cool project, but I want you to understand it. Does that sound good? I hope it does. And so what I need to do is I'm just going to take a second. Let's just take a very brief second and talk about why people hate trigonometry so much. The reason they hate trigonometry is because they don't understand it. And the reason they don't understand it is not being taught well in school. And so there's kind of three fundamental mistakes that are being made when trigonometry is taught in school. The first mistake is it is taught without any context. It's taught without any context. It's completely abstract, so it becomes an exercise in a student trying to memorize a huge amount of identities and a huge amount of techniques, be given a problem, and try to remember which of those myriad of identities that were memorized are appropriate for this particular problem. So it's just simply an exercise in rote memorization, not understanding. What I will teach you is you don't have to memorize anything. You're just going to understand it. Now, the second problem is the teachers in the schools and the classes make it way, way, way too complicated. You're taught sines and cosines and tangents and cotangents and cosecants and arctangents and hyperbolic cosines and all of these different things. And the truth is, to work most problems, you don't need all of that. Almost any problem in trigonometry, you can work with sines and cosines. And the problem is what they're doing is they're teaching you 50 different ways to solve the same problem. What I'm going to do is I'm going to teach you one way, and I'm going to teach you to understand it. And then we're not going to need to know what a cotangent is, or we're not going to need to know what a secant is. Okay, we're going to learn sines and cosines. I'm going to show you how you can work just about any problem with those two things. I'm going to teach you how to understand it. The third reason you have trouble understanding trigonometry is it's taught to you in the framework of triangles. But at its core, trigonometry is not about triangles. It's about circles. And if I teach you trigonometry based on a circle, I think all of a sudden it's going to make sense. Okay, are you guys willing to give it a shot? Leave a comment down below. I'm in. I'm not going to panic. I'm going to assume if this guy could teach me Arduino and Raspberry Pi and Fusion 360 and all that stuff, he can teach me trigonometry. So at least give me a chance. Okay, at least give me a chance. So we are going to switch over here to the old sketch pad. And what am I going to draw? I'll start by drawing a triangle. No, I will not start by drawing a triangle. I will start by drawing a circle. I will start by drawing a circle. Okay, so let's come in, and I'm going to try to be extra neat and careful on this one. It's kind of hard. You get in a hurry, and when you get in a hurry is when you start not doing things perfectly neat. And so let me come in here right there, and then I will come down. That looks good, right like that, and boom, that is a pretty darn good circle, I will say. Now, anytime we're dealing with something in math, it's always good to drop a coordinate axis so we can think in terms of x and y values. And so let's see if I can come in and give you a nice coordinate axis. So let's drop an x-axis across here. That looks pretty good. And let's drop a y-axis down like this. Okay, so we've got the origin in the middle, we've got an x-axis, and we've got a y-axis. Okay, now we had that homework assignment a few lessons ago where I was teaching you about the OLED display, and what it was that you needed to do was to draw a circle. And you guys really struggled mightily at putting a circle on your OLED display because you really didn't understand the math. So you were running out trying to find a library that would do it for you, or you were randomly Googling things trying to find an equation that would give it to you, to where really a circle is a very easy concept if you think of it conceptually. So I want you to think that my stylus here, I want you to think of my stylus as being a unit of 1 in length. It doesn't really matter what unit. Think of it as 1 foot, 1 inch, 1 mile, whatever, but think of this as a vector of length 1. Now I'm starting to point it at 0 degrees along what to me is the positive x-axis, okay, and I've got an angle of 0 degrees. Now I'm going to rotate all the way through 360 degrees. So I go to 90, I go to 180, I go to 270, and I go to 360. The tip of this stylus just traced out a what? It just traced out a circle. So if you want to draw a circle, all you have to do is you have to have a radius of unit 1, and then you've got to capture the x and y values of the tip of the stylus, and you will have a circle. So let's see if we can draw that. Let's see if we can draw that over here, okay? So what I'm going to do is I'm going to draw a radius, and that radius is going to have that vector is going to have a unit of 1, and so I will come over here and just kind of remind us not to forget that the radius is equal to 1, and this is a vector, and it is spinning through some angle, okay? If I take that angle from 0 through 360 degrees, then this tip is going to trace out a circle. So what do I need to know? I need to know the x value of the tip, and I need to know the y value of the tip, right? This is a point, and it's got an x and y value, and I just have to capture those x and y values as I take theta, the angle, from 0 to 360. So let's see if we can make that a little bit clearer. Let's see if we can make that a little bit clearer by drawing a triangle. And so I'm going to come down here, and I am going to take this point, and I'm going to drop it down to the x-axis, and I didn't do perfectly good on that. So I'm going to come here, and I'll drop it that way. And then I'll come over here and drop it that way. Okay, and so what do we have? We have here, if I come over how far? X, and then I go up how far? Y. So if I go over by X and up by Y, where do I end up? I end up at the point X, Y. Pretty simple, right? Well, now, how do I get that X and Y value? It's really, really very simple. the x value is simply equal to the cosine of the angle, right? The cosine of the angle. Well, what is the y value? The y value is the sine of the angle, like that. The x value is the cosine of the angle. The y value is the sine of the angle. Well, where do you get sine and cosine? Well, you could use your calculator, okay, or you could look it up, or you could calculate it in MicroPython in your Thani program. So there's lots of places to get sine and cosine. That gives you x and y. Now you can make a circle. Now, how easy is that? Now, there's just a couple of very simple caveats that I have to give you. Now, we as normal people, we think in terms of degrees, right? And so you know that out here at the positive x-axis, we start at 0 degrees. When we rotate that vector straight up, we are at a what? We are at a 90-degree angle. Okay, we are at a 90-degree angle. And then when we come around another quarter, we are at 180 degrees. Then we come 90 more. When we're straight down, we are at 270 degrees. And then when we go all the way around back to 0, that is 360. So we can see an angle of 0 is the same as an angle of 360. It's just you've gone all the way around. We are very good, and it's very intuitive for us to think like that. But most programming languages don't use degrees. They don't use degrees as their unit of measure. What they use is they use radians, okay? There are 360 degrees in a circle. There are 2 pi radians in a circle. So how would that work? Well, in radians we would start here at 0 radians. Now, what if we went halfway around? That would be what? That would be pi radians, right? If 2 pi in the full circle, how much in the half circle? Pi. Well, what if we go half of that? Half of pi would be pi over 2. And what you got to see is as you're going around, you're counting by pi over 2's. 0 pi over 2, 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and 4 pi over 2. 4 pi over 2 makes 2 pi. And so what you got to see is you're just counting by pi over 2's. Okay, so that's 2 pi over 2 is 2 pi. And then so it's 1 pi over 2, it's 2 pi over 2, and then it is 3. Let's try that again. Then it is 3 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, and then what? 4 pi over 2 reduces down to 2 pi. Okay, so just so as you go 0, 90, 180, 270, 360, in radians you go 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Okay, so now we think in degrees, and the programming languages usually want radians. So how do we do the conversion? Well, let's talk first of all about how to go from degrees to radians, because that's usually the direction that you want to go. So how do I calculate radians? Well, radians is equal to, what you got to think about is what fraction of a circle have I gone around? In degrees, what fraction of a circle have I gone around? Well, the fraction of a circle that I've gone around is however many degrees that I have divided by 360. And then you multiply by your new units, which is 2 pi radians in a full circle, okay? So you take the degrees that you have, you divide by 360, and you multiply by 2 pi, and then you are in radians. If you want to go 2 degrees from radians, it's very similar. The degrees is equal to the fraction of the circle in the existing units, which is how many radians you have divided by 2 pi. times the full circle in the new units, which is 360. So here you can go radians to degrees, here are degrees to radians. Here you can go radian to degrees. Okay, so you need to write those down. These are the kind of 4 things that really are going to get you through most of your problems here if you just learn those 4 things. Okay, so let's jump in and let's see if we can start playing around with that a little bit. We just remember the x value is cosine theta, the y value is sine theta, and we have to usually convert from the degrees that we think into the radians that the computer program wants, all right? So let's see if I can work a sample problem, and I think what I should probably do is I think I should probably start with a clean picture. So let's come in here. Okay, let's see if we can start with a nice clean circle. And I'm going to try to do this as carefully as I can. There, that looks pretty good. Let's go ahead and drop our x and y axis just because that will kind of help us keep track of the math. That looks pretty good there. Okay, now let's come in and let's put a radius. Okay. This time what I want to do is I want to try to come in and I want to try to go to 45 degrees. Okay, so I'm going to come in and I'm going to draw that at a 45-degree angle, and then we can play around with that. Let's see. That's not a very good 45-degree angle. I think I missed it, and so let's try to draw it again a little bit more carefully. And coming right here, that is exactly the 45-degree angle as best as I can draw it. And so here we are. So what do we have? We have a 45-degree angle. And now let's come in and just see if we can kind of draw that triangle. And so I will drop this side from here like that. And then I'll come over from here. And then what do we know? We know that this is the x value, and we know that this is the y value, all right? And then what do I know? I know that x is equal to the cosine of 45, and I know that the y value will be equal to the sine of 45. But now what do I need to do? I need to convert those. I need to convert those to radians. So I'm going to say x is equal to the cosine of, and this would be 45 divided by 360 times 2 pi. So I'm converting them inside of the function. And y is going to be sine of 45 divided by 360, converting those to radians, those degrees to radians, times 2 pi, like that. Okay, now let's just look at this and let's see if we could roughly approximate what the sine of theta and the cosine of theta for the 45 degrees. Let's see if we can roughly approximate that. Well, that is from here to here is 1, so this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and it's a little bit past 0.7, so that x value looks like about 0.71, and the y value is 0.1, 2, 3, 4, 5, 6, and again, it's just a little bit past, 0.7, and so the y value looks like 0.71 as well, and I'll just say approximately that. All right, so now let's jump in and see what happens if we come over and do a little bit of math here, if we do it a little bit of programming. Okay, so how do we find sine and cosine? How do we find sine and cosine in MicroPython? Well, the first thing we need to do is, let's come over here. I need to first of all import math. So I'm going to import math like that. And now what do? I can just come in and I can say I want math dot cosine. Math dot cosine of what? Well, it was 45 divided by 360, okay, and then times 2, and then times pi. What's an easy way to get pi? I could just put 3.14, or if I wanted it more precisely, I could say math dot pi, and it would give me pi out to a lot of different decimal points. So let's come in and say, what is the cosine value? This would be our x value over here, and look at that. It says that the x value up here would be, the x value would be 0.707, which is very close to our approximation here of 0.71. Okay, let's see what the y value would be. The y value would be, this time we would do what? Math dot sine, and this time still again 45 divided by 360 times 2 times math dot pi, and what do we get? What do we get? We get the same thing, 0.707. So let's put that over here, 0.707, like that. And so what do we see? The sine and the cosine of 45 degrees is the same number, and it is 0.707. Does that make sense? Well, think about it. If you have a 45-degree angle, if you have a triangle with a 45-degree angle, what do you know about the two sides? You know about the two sides have the same length, and so therefore the 45 degree would have the same sine and the same cosine because the x value and the y value are the same. And so that really makes a lot of sense, doesn't it? That makes a lot of sense. So let's see here. Let's see if we can try another one. And I should have done this a little bit differently, but let's just try one more. Okay, let's just try one more. And what I will do is, I think I could probably back through this. I'm sorry you got to watch this, but let's see if I can just, that's too painful. So I'm going to come over here. And I will come over here and I will just clear it, and then we will draw another circle, and I will try to do this as carefully and succinctly as I can. And we come down here like this, just like before. We will put our x-axis in. Okay, we will put our x-axis in. We will put our y-axis in. Okay, and this time, let's say that we went to about 60 degrees. Okay, let's say that we went to about 60 degrees. And so I am going to draw an angle of about 60 degrees and come up here like this. Okay, what is this angle? This angle that I just drew is approximately 60 degrees. Okay, and now I'm going to have down to right here, let's draw that triangle. Okay, I'm going to have, now, I'm going to have an x value. I'm going to have a y value, and this is going to be x and y, and x is going to be equal to cosine of the angle, and this y is going to be equal to sine of the angle. And what is that going to be? The x is going to be cosine. What was the angle? The angle was 60, converted to radians, so I divide by 360 and multiply by 2 pi. And then y is going to be sine of 60 times 2 pi. divided by 360. And now let's see what those two values are for x and y. So I can come back over here and I can just kind of call this up for the sine and the cosine. Let's start with cosine. And still here, instead of 45, I will say this is 60. Okay, and what does the x look like? The x looks like it's about half the radius, right? The x looks like it is about half the radius. And what do we get? We get the cosine is 0.5. And so that looks exactly what we would expect. Okay, and what does this look like? 0.1, 0.2, 0.3, 0.4, 5, 6, 7, 8, a little bit more than 0.8. And so let's come in here and let's say for 60, this time we are going to do sine. Like that. Okay, in 0.86. So just sort of like what we were expecting, 0.5 and 0.86, we could approximate it just by looking at the graph. Okay, so let's see what we have learned. We have learned that the x value is the cosine of the angle, the y value is the sine of the angle. We've done a couple of quick examples. We've learned that you've got to convert from degrees, which you think into radians. I've shown you how to do that. Now, there's a couple of other little caveats that I have to give you, and let me give you those caveats, okay? So let's say that over here, instead of having a radius equal 1, what if I had a radius equal 4? What do we do there? Well, we just scale everything by the radius. So now x is really equal to 4 times cosine of theta, and y is equal to 4 times sine of theta. So more generally, the equations that you have is x is equal to the radius times cosine of theta, and y is equal to the radius times the sine of theta. And a lot of times we have the radius equal 1, and when we have the radius equal 1, it just drops out. Okay, but if the radius is not equal 1, we just scale everything by the radius like that. Okay, so first caveat is you've got to convert from degrees to radians. The second caveat is if your radius is not equal to 1, you've got to scale things by the radius that you have. All right, does that make sense? Okay, now this will be something else that you're sometimes going to have to be able to do. Sometimes you are going to be given the x value and you're going to need to find the angle. Sometimes you're going to be given the x value and you're going to need to be able to find the angle. Or sometimes you're going to be given the y value and you're going to need to be able to find the angle. Okay, how do you do things in that case? Well, there is a go backwards function, and that is the arc sine and the arc cosine. And that is, if I'm given the x value, I can find the angle by taking the arc cosine of the x value, or if I'm given the y value, I can find the angle by taking the arc sine. So let's see how that works. Let's take that example that we just did. Let's take that example that we just did where the x value was 0.5 and the y value was 0.86. Well, if I want to find the angle is going to be equal to, you can do this two different ways. I can say that it is the arc sine, the a sine, the arc sine of the x value, which is 0.5, or the angle is equal to the arc. That I did that wrong. Let's see. I said it backwards. Okay, the angle would be the arc A cosine of the x value, which is 0.5, or the angle is equal to the arc sine of 0.86. So let's try that. Okay, let's try that. Let's come over here and let's play around with that a little bit. And I can see that you cannot see that, so let me turn my title off there for a second. Okay, give myself a little bit more room there. Okay, so you can see how that, what I'd written back there. Okay, so now let's play around with that a little bit. We will come over here, and we've already imported math, so we don't need to import math again, but let's just see what happens. Okay, so what I'm going to just say is, what is the arc sine? I got to do math dot arc sine, that's backwards sine, or I'm going to do cosine first, backwards cosine, arc cosine of what? 0.5. Okay, and that comes out to 1.047, where we were expecting 45, okay, or we were expecting 60. Well, what is this? This is in radians, so we've got to convert it to degrees. So I take my radians like that, which I just got, and I would what? I would divide it by 2, and I would divide by math dot pi, and then I would multiply it by 360. Okay, and boom, I get 60 degrees. Now let me show you a little bit better way to do that. Really what I would like to do is, just because I want to be more deliberate with my parentheses, I would say math.arc cosine of 0.5, and then I would divide by, open parentheses, math.pi times 2, all of that in the denominator, and then multiply by 360, and that will be back in the numerator, and we get 60 degrees. Okay, what if we wanted to do it with the arc sine? We would have arc sine, and we are going to put in arc sine of 0.86. And remember, this was rounded off a little bit, so this one won't come out to be exactly 60 degrees, but 59.3, because that 0.86 was a little bit of a rounded number. Okay, what have we learned in this lesson? We have learned how to convert from degrees to radians, from radians to degrees. We've learned how to find the x and y coordinates along a circle. X is cosine theta, y is sine theta. We have learned that if you have a radius that is not 1, x is r times cosine theta, y is r times sine theta. And then we learned that there's an undo function, arc cosine or arc sine, that will take you from the x value back to the angle, or from the y value back to the angle. So that is some pretty good stuff. There is one other thing that I would like to show you. There's one other function that is a little bit interesting, and that is, let's come back over here and let's look at this. Let's look at this radius here, right? Let's look at this radius here, from here to here. What if you wanted the slope of that? What would the slope be? The m? Well, it would be the rise over the run, the increase in y over the increase in x. It would be y2 minus y1 over x2 minus x1. Well, the origin is 0, and so it would become just y over x. Okay, and what would that be? That would be the sine of the angle over the cosine of the angle. That would be the slope of that vector, and that would be kind of useful to know. And so let's come over here and let's see if I can put that in, and let's see if it looks a little bit about right. So what I could say is, I could say that that is going to be math.sine. The slope of that line is going to be math.sine of, and I might be able to just come up here and snag that. That will make it a little bit easier for me instead of typing it in. So the sine of that 60 converted to radians, okay, divided by math.cosine of that 60 converted to radians. And then I need to close that parentheses, and then let's see, this should give me the slope. And what it says is that slope is 1.7. In other words, I go up by 1.7 and I go over by 0.5. And it's a positive number. That actually looks kind of good. That looks about right. But what I'm going to show you is there is a special function, and that special function gives you the slope, and that is the tangent function. And what I'm going to tell you is there is a special additional thing, which is tangent, and tangent of the angle is just the sine of the angle divided by the cosine of the angle. And let's see if we can do it that way. What if I just say math.tan of what? Math.tan of that whole thing. That's 60 converted to radians, and boom, it's the same thing, 1.7. So I've taught you sine is the y value, cosine is the x value, and tangent is just sine over cosine, or y over x. And tangent is actually kind of useful. So you need to know cosine is the x value, sine is the y value, and tangent is the y divided by the x, the sine divided by the cosine. And now you have a pretty useful set of tools for you guys to move forward with the future lessons. But I'm going to give you a homework assignment, and I'm going to ask you to do this. Well, let me show you one other thing. Let's say instead of being at 60 degrees, what if we went to 120 degrees? Okay, I want you to go to 120 degrees, all right? And so what I'm going to do is I'm going to come over here, and I'm going to draw a vector where I come up to 120 degrees. And so here we go past 90, and we go past 90. Okay, we're going to go past 90, and we're going to go all the way to 120 degrees. Okay, now if I am at 120 degrees, what do you expect? What do you expect the sine to be? What do you expect the sine of 120 to be? Sine of 120 degrees to be? See if you can just kind of think through that. So I'm going to go back to math.sine. Okay, and here on math.sine, instead of going 60, okay, I'm going to go to 120. And what do we find when we do that? The sine of 120 is the same as the sine of 60. Why is that? Because I'm as far past 90 as I was before, and I end up with the same length on that vertical leg. But now tell me, what do you think is going to happen with the cosine? If I take the cosine, what do you expect? Okay, you might say that you expect it to be the same as well. But what do we see? All of a sudden, instead of 0.5, I have what? I have minus 0.5. And why is that? Why is it minus 0.5? Well, just look at the picture. Okay. If I drop it here, this has a length of 0.5, but it's a minus 0.5. It's along the negative direction of the x-axis. So you see I can have minus 0.5 because I'm on the minus x-axis. So you can see here, you can see that you're going to have both positive sines and negative sines. You're going to have positive cosines and negative cosines, but it's not at all confusing. Why? Because you just look what? This is positive x in this direction. This is negative x in this direction. This is positive y in this direction, and this is negative y in this direction. You just got an xy coordinate, right? Just a good old-fashioned xy coordinate. Okay. Let me give you a quick homework assignment, and then we will have one more trig lesson. Okay, I've kind of explained everything to you with circles, and now next week what I'm going to do is I'm going to give you practical problems, and where we'll kind of drop off and move from the circle to the triangle, but now the triangle will make sense because you've understood it all in the context of the circle. So let me come here and let me clear this, okay? And so this is what your homework assignment is. This is your homework assignment, And what I want you to do is I want you to find the sine of theta and the cosine of theta. And I want you to find it for 0 degrees, for 90 degrees, for 180 degrees, for 270 degrees, and then for 360 degrees. But I want you to do it without a calculator and without using Thani. I want you to do it just by looking at that circle that we had. We look at that circle and you think, I'm at 0 degrees. What would the cosine of 0, what would the sine of 0 be? And I want you to fill out this chart without using a calculator or without using Thani. And you can actually do that if you just look at the picture and think, and then that shows me that you actually understand it. Okay, guys, how painful was this? Was this just terribly painful? Or is trigonometry starting to make a little sense? Okay, I hope it's starting to make a little sense. We're going to do one more lesson that's based on what we learned today. And then what we're going to do is we're going to jump into this project over here that I was showing you earlier. And this is why you got to learn this. Okay, this is why you got to know how to do this. Let me see if I can call this up. Remember, this is our little tiltometer here that we developed where it is sort of like a digital level. Well, in order to do this project, you've really got to understand the trigonometry. And I don't want you to just go in and memorize and copy what I'm typing in. I want you to understand it to the point that you can actually do that project by yourself. Okay, sound good? Guys, I hope you're having as much fun taking these lessons as I am making them. I want to, as always, give a shout out to you guys who are helping me out over at Patreon. Right now, you know, the direction YouTube is going is not towards stagio guys teaching math. Really, they're putting their advertising revenue into these silly little 15-second shorts. And so those of us doing content-rich, deep content are really, really getting treated harshly. You guys that are helping me out over at Patreon, you're the one you guys are the ones that are keeping me here making content week after week after week. And I thank you for that. You guys that are not helping out yet, look down in the description. There is a link if you want to kind of think about hopping on over there and helping me with that. Also helps me if you give me a thumbs up, helps me with the old YouTube juice if you'll leave a comment down below. Subscribe to the channel if you haven't already, but most importantly, share these videos with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.